Good morning, everyone. Welcome to English Medium Prep by Jampur. I'm Kumar Ravi, and I welcome all the students on this session. Today, we will continue the same chapter with the same enthusiasm. And guys, so just join this session as soon as possible, and we will start a new topic here. Okay, but the chapter will remain same, and this chapter is very important for the exam, as I have already told you that two or three questions are asked in every exam based on from this chapter. Okay, so this is this session is has to be gone very fantastic, and I hope that you will enjoy this session. So guys, first of all, I will tell you about our official application, that is Exampur official application. Okay, so you will get a lot of benefits from the application if you download into your mobile phone. Okay, so I will explain these benefits in detail later. Okay, but first of all, we should start our session. So guys, please do like and subscribe this channel. Please do like this session and share this session among all your friends so that they can also watch this session. And I would say that please note down all the theory whatever I teach here on the board. Okay, because it may be very helpful for you in the exams for the revision. Okay, during exams. So let us continue. As yesterday morning I had discussed about the reflection, and then after at 2 p.m. session I discussed about the refraction. Okay, but the refraction portion was not completed actually. Okay, so you can watch the theory of refraction in 2 p.m. session also. Okay, so I will teach the theory as well as the problems in both the sessions including. Okay, so let's discuss. When we talk about the refraction, as I have already told that when a light ray goes from one medium to another medium, okay, when a light ray goes from one medium to another medium, light ray deviates from its path. Okay, so as well as there are some changes in the wave parameters actually. Okay, so I will let you know those parameters in which the changes are observed. Okay, so we will write it as refraction. I had to explain the refraction. Okay, so when we talk about the refraction, when we talk about oh sorry, when we talk about the refraction, when we talk about the refraction, suppose that uh, So guys, here we have discussed refraction. Here we have discussed refraction, that you can see that uh, this is a light ray. Suppose that this is the boundary, medium boundary, known as medium boundary, and the upper side is of rarer medium and the lower side is of denser medium. Okay, so and this is the normal, dash 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 is a normal is a perpendicular line which makes an angle 90 degree to the surface. Okay, when a light ray is incident at an angle I with the normal, then it refracts, okay, with angle R. Refracts means it enters into the other medium which makes an angle R with the normal. Okay, and when the light ray goes from rarer medium to denser medium, rarer to denser, okay, rarer to denser, it bends towards the normal. Okay, it bends towards the normal. Okay, so suppose that so now we can find out, okay, there is an index of, which actually represents the ability of the medium to deviate or to change the path of the light ray. Okay, that is actually known as refractive index. Okay, so refractive index of the denser medium can be calculated like this: sin I upon sin R. I is the incidence angle of incidence, and R is the angle of refraction. Okay, so this can also be written as, guys, these angles depends upon the speed of the light in their respective mediums. Okay, so C is the speed of light in the medium which is in which the angle of incidence is I. Okay, then the speed of the light will be depending upon the angle R which is in the medium 2. Okay, so these are the basic concepts of refractive index, and now we can see that the basic examples, which are in our daily day-to-day life. Okay, so we can see, here we can see that this is a river, just like this is a river, and there is a clean water. Okay, there is clean water. A coin has been placed at the bottom of this water river. Okay, then the light ray going from this coin to this eye, will be like this. Okay, will be like this. When this light ray will go from denser medium to rarer medium, it will bend. Okay, or it will deviate from the normal. Away to the normal. Okay, away to the normal. Then this light ray will fall into the eyes of this observer, and this observer will fall that this light ray is coming from this point. Okay, hence we can say that actually the coin has been placed at this place, but it will be appearing like this. This coin will be appearing that this coin has been placed at this point. Okay, so this will be the image of the coin. Like this will be the image of the coin. Okay, but this is the object. Okay, so similarly the thing, you can observe that if the coin appears rise and above, then obviously this ground level would also will appear rise and above. Okay, so this is a very good example of refraction. Here we can see that if we fill a glass of water, okay, if we fill a glass of water and place a coin at the bottom of the glass, then we can observe that this coin appears rise and above. Okay, at my childhood, when I used to go to a doctor when I was ill. Okay, so at that time I used to see a glass placed on the table. Okay, and there were some visiting cards which have been placed in between the table and the glass. Okay, so those visiting cards would have been appearing rise and above. Those visiting cards would have been rise and above. Okay, so that was actually just because of the refraction. Okay, so when a glass slab is placed on the printed paper, then the letters appear rise and above. Example: light reaches us before sunrise. Light reaches us before the sunrise and remains after the sunset because of atmospheric refraction. My dear students, we can observe that light ray, suppose that this is earth, suppose that this is earth, okay, suppose that this is earth, this is earth, okay, so this is earth, and suppose that this is sun, okay, and suppose that this is sun, here is sun, like this, okay, so this is sun, okay, so this is, suppose that this is sun. Suppose that this is sun. Now this is earth, and now suppose that this is earth, okay, so this is earth, okay, so we can see that suppose that this is atmosphere, suppose that this is atmosphere, okay, now we can see that suppose that there is sun, sun is located at this point, okay, now you are residing at this point, you are residing at this point, you are residing at this point, so here you can see that light ray appears, light ray enters into the atmosphere at this point, but these light rays, bends like this, okay, bends like this because these light rays enters into the atmosphere, enters into the atmosphere, enter into the atmosphere, enter into the atmosphere, okay, so these light rays enter into the atmosphere like this. So here we can say that, so this kind of bending, actually this kind of bending of light, this is nothing but the, this is nothing but, this kind of bending, this is nothing but the atmospheric refraction. Atmospheric refraction. Okay, so when the sun rises, even though we cannot see the sun, but the light ray coming from the sun get bends, okay, and that's why that light ray reaches to us, okay. So this is the example. So my dear students, here you can see that this is a very good example of atmospheric refraction, and the twinkling of stars is just because of the refraction also, okay. So example, twinkling of stars. Twinkling of stars occurs due to, twinkling of stars occurs due to atmospheric refraction. Atmospheric refraction. Twinkling of stars occurs due to twinkling of stars occurs due to atmospheric refraction. Atmospheric refraction. Atmospheric refraction. Atmospheric refraction. Okay. So yes. So this is the twinkling of stars. Okay. So guys, you can just note it down. These are the very important concepts. So this is refraction of light. Let me explain the dispersion of light. Let me explain the dispersion of light. Okay. So this one is also very important, dispersion of light. So this one is also important. Dispersion means splitting of light, but in a pattern. Dispersion means splitting a light in a pattern. Okay. So actually when we see like this, okay, suppose that this is a prism. What is prism? A heart shaped solid, or a thin sheet. That can also be a thin sheet also, okay, but the transparent, this is known as the prism, okay. So such kind of thing is known as the prism. So now here you can see that, here you can see that uh, this is the light ray, okay. Suppose that this is the light ray, this is the white light ray actually, okay. So this is the white light ray like this, and we can see that the light rays get displayed. Oh, light ray displays like this, okay. It splits like this, light ray splits like this, okay. And suppose that this is V O. Suppose that this is VIB, okay, R. VIBG by OR, okay. So okay, so this is white light ray. Hmm. Mm-hmm. White light ray, okay. So these are the prism, okay. So here we can see that these are the 7 colors which get splitted in these, okay. Suppose that this is suppose that this is actually red, and this one is of violet color, okay. And this one is of orange color, this one is of orange color, okay. And this one is of yellow color, and this one is of yellow color, and this one is of green color, this one is of green color, okay. So this one is of green color, and this one is of blue color, okay. And this one is of indigo. Yes, this is because of violet. Yes, this is because of, this is the indigo. And suppose that this is the indigo, this is indigo, okay. Let me clear all these colors like this, make some space in between them. This is the green color, okay. And suppose that this is the blue, this is the indigo color, this is indigo color, okay. This is indigo color. And now suppose that this is blue color, okay. And now suppose that this is blue color, this is blue color. Now suppose that this is blue color, so this is blue color, okay. And this is indigo, and this is green, and this is yellow, and this is orange, okay. So these are the 7 colors actually. So these are the 7 colors you can see here. So white light ray always splits into the 7 different colors, and this is known as what? Splitting of light or dispersion of light, okay. But when we compare all these colors with the wavelengths, then obviously we can see that wavelength of color, okay. So my dear students, compare with all these things. Red color possesses the longest wavelength, okay. Red color possesses the longest wavelength like this, okay. But the orange color has the second one. So orange color has the second highest, okay. orange color possesses the second highest, but the yellow color possesses the third one. Okay, but the green color possesses the fourth one. Green color possesses the fourth one. Okay, so green color possesses the fourth one, but the blue color possesses the fifth one. Okay, so blue color possesses the fifth one, but the indigo color possesses the sixth one. Indigo color possesses the sixth one, but the seventh color possesses, but the second color possesses the this one. Okay, so here you can see that this is the order of the wavelength. Now you can observe that from violet to the red, the wavelength increases. Okay, so from violet to the red, wavelength increases. So violet to the red, wavelength increases. Wavelength increases. Violet to the red, wavelength increases. Wavelength order. Okay, so let me write this. So these are the wavelength order of wavelength. Okay, so here you can see that if this is the order of the wavelengths, then obviously you can see that from violet to the red, the wavelength order increases. Okay, it means the wavelength increases. So guys, so this is the order. Okay, since here you can see that the red color light has the highest wavelength. Okay, red color light possesses the maximum or highest wavelength, and this is the reason that red color light can be seen from a long distance. And this is the reason that red color light can be seen from a long distance. Red color light can be seen from a long distance. Red color light can be seen from a long distance. Okay, so red color light can be seen from a long distance. Red color light can be seen from a long distance. Okay, so yes, here you can see the red color light can be seen from a long distance. Okay, and here you can see that yellow color as the is at the third position and green at the fourth position. By sequence, by reasoning, simple reasoning by the sequence, we can see that green color is the middle color. Okay, green color appears to be the middle color, but it is not so. Okay, guys, yellow color is the middle color among all these 7 colors. If you see the actual spectrum of white light ray through the prism, then you will see that yellow color is in the middle color, and hence as well as the middle color covers a wide range of wavelengths, and this is the reason that our eyes are becomes habitual. Our eyes become habitual of watching or observing anything in sunny light. Okay, sunlight, and actually, or we can say that, or in yellowish light. Okay, you can simply differentiate the tube light, the light ray coming from the tube light, and you can observe the light ray with the sunlight. Okay, so you will find that sunlight ray has the yellowish nature, but the light ray coming from this tube light has not the yellowish content. Okay, yellowish nature. So this is the reason and this is the reason that our eyes becomes too much sensible for the yellow colors, and hence this is the reason that school buses are made yellow. Okay, warning signboards are made yellow, and whenever I visit any metro station platform, then I used to listen some announcements that passengers are requested to stay behind the yellow line marked on the platform. Okay, so that is just because of actually it is to just beware the passengers. Okay, so that no one can move, no one goes outside the yellow line. Okay, so yellow line is nothing but just like a warning signboard. Okay, so when sometimes I have also observed that when my dish TV recharge is to be going to be finished, okay, then actually a triangle shaped yellow colored triangle actually appears on the right side of the screen of the TV. That actually is the symbol of that you have to recharge your set-top box. Okay, so this is nothing but the warning symbol. So here we can see that dispersion can be written as dispersion can be written as dispersion of light can be written as when a white light ray when a white light ray passes through a prism, it deviates from its it deviates from its path. 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 Okay. It deviates from its path. So this phenomena is known as sorry. It deviates. It splits into 7 colors. It splits into 7 different colors. Okay, in a pattern. It splits into 7 different colors in a pattern. This phenomena of light is known as this phenomena of light is known as dispersion of light. Okay, so this is nothing but the dispersion of light. You can see the example of dispersion of light just after the rain. Okay, so formation of rainbow. Formation of rainbow. Okay, so this is the example. So guys, here and red color possesses the maximum wavelength. Okay, so here you can see that there is a less deviation. Okay, guys, you can observe that this is the original path. Okay, but the red color light has the deviation. Okay, so red color light has the least deviation. This is delta R, but the violet color possesses the maximum deviation. Okay, so violet color possesses maximum deviation. Here we can see that Here we can see that red color light. We can see that red color light we can see that red color light possesses the maximum wavelength. Okay, maximum wavelength and minimum deviation and minimum deviation. Minimum deviation. Okay, so yes, here we can see that the red color light possesses maximum wavelength and minimum deviation and minimum deviation. That's by red color light that's the red color light this is the reason that red color light is used as danger signal. Is used as danger signal is used as danger signal in signal system. In signal system. So this is the basic concept. Okay, so this is the application. So this is the application actually. Okay, so guys, you can see here, you can see here. So this is the application of dispersion of light. So this is the application of dispersion of light. Okay, so tomorrow we will learn some more examples of dispersion of light. Okay, and today we will stop this lecture at this point. Please do share this session among all your friends and like this session among all your friends. So guys, I would like to tell you one thing that this is our official application. You can download, and this is the way to download. Just go to the Play Store and then search Exampur, and then you will see Sarkari Nokri Prep, and then just open that and register like this. Okay, you will have to fill that form, and after registering you will have to log in, and then okay, and then you will see there are many types of courses. Okay, you will see such kind of dashboard actually. So here you will see the paid course, live paid course with test series, free subject wise, topic wise quizzes with all report card, job alert, admit card and date, exam date, all exams, previous year's questions, paper solution, free all India scholarship test with report card, topic wise free live classes, free full length sectional test with report card, free exam wise PDF and practice set PDFs, daily, weekly and monthly current affairs, unlimited subject wise practice questions. Okay, so this is the dashboard actually, you can see here. Okay, so I hope that this will boost your preparation if you download this application into your mobile phone, and you can get the benefit of these things. Okay, so you can just join our paid batches also. There are a lot of things, there are a lot of benefits from the paid batches. You get the live courses, live classes, as well as the doubt session, as well as the PDF notes, as well as the test series, as well as the previous year's question solution also. Okay, so these are the some benefits of our application. So download this app and share this link among all your friends, relatives and everything. Okay, so thank you so much. Have a nice day. Bye bye. Take care.